This is how an atomic weapon looks like. In this video, you will learn the science and the components of an atomic weapon called FATMAN, which was dropped on Nagasaki. Let's remove these two outer metal layers. This is the main physics package. So at its center, we have a plutonium-239 sphere. This is about 9.2 centimeter in diameter, which is mainly used for the nuclear fission process. But what actually is nuclear fission process? Let's say this is the stable plutonium atom and this is the neutron, and when I strike it very fastly, it becomes unstable and splits into two smaller atoms, zirconium and xenon. While releasing more neutrons and energy, these neutrons strike the other plutonium atoms, causing them to split and release even more neutrons. This splitting of an atom is called as nuclear fission. So question arises, from where does these initial neutrons come from? In a plutonium sphere, there's a neutron initiator. It has a sea urchin shaped polonium sphere, which emits these alpha particles, and an outer beryllium shell, which absorbs these alpha particles and releases out the neutrons. Covering plutonium, there is a layer of uranium-238. It reflects the neutrons back into the plutonium. But when fast neutron strikes it, uranium-238 also undergo fission process. Plutonium and uranium together form a fission core, roughly the size of the football. On top, a thin layer of boron which covers it. It absorbs slow-moving neutrons and prevents it from pre-detonation. And then a thick layer of aluminum covers it. And 32 explosive blocks covering the whole arrangement. But why do we need these explosive blocks? In a plutonium sphere, if the atoms are too far apart, the chain reaction slows down and eventually stops. When the chain reaction cannot be sustained, the plutonium is said to be at subcritical mass. To prevent this, the atoms should be brought closer to each other, or in other terms, the density should be increased. When the chain reaction can sustain itself, the plutonium is said to be at supercritical mass. To achieve this, explosives are placed around the plutonium and triggered. The explosion compresses the plutonium and make it supercritical. Now, let's look into the explosive block. Each block is divided into two layers, the booster layer, explosive lens layer. This is made up of faster explosives. This is the combination of slower and faster explosives, and this plays a very crucial part. When faster explosives are triggered, it creates a convex-shaped explosion wave, which would compress the plutonium unevenly. To fix this, explosive lens is added. As the explosion reaches lower explosive, the explosion wave changes from convex to concave in shape, and plutonium sphere gets symmetrically compressed. An EVW detonator is placed on each block and a duraluminum case which covers this physics package. At back, we have an X unit with high voltage capacitors and batteries. Wires from these batteries are connected to the 64 terminals and then to the EVWs. At front, we have timers and baro switches. Upon that, we have an RT radar unit, which is connected to the 4 different antennas. And lastly, an outer steel shell, which covers this whole assembly. On August 8, 1945, the FATMAN was loaded into a B-29 bomber named Boxcar. The plane took off at 2:47 a.m. from Tinian Island to the actual target, Kokura. But it was completely covered with smoke and clouds. The bomber then turned around to the secondary target, Nagasaki. At 11 a.m., the FATMAN was dropped. It had a free fall of 43 seconds, and at 500 meters from the ground, RT radar unit triggers the X unit. So the high voltage current from these batteries are passed on to the EVWs. EVWs ignites the explosive blocks, creating an implosion shock wave. And the shock wave starts compressing the inner layers. In a plutonium sphere, as the neutron initiator gets compressed, the polonium spikes pierces the beryllium shell and neutrons are released, which sets off the fission process and releases 21 kilotons of energy in a blink of an eye. From the center, up to 2,500 feet, everything is destroyed. Even a couple of miles away, people were badly burned. These are the before and after pictures of Nagasaki, revealing the destruction caused by the FATMAN.